friends, these notes are really long because there's a bazillion and one examples, so there's a chance that I'm going to make this in 2 parts, but we'll just get started and see how it goes. All right, we are going to talk about something you have talked about many times before, and that is called a function. This is going to be a lot more concept than it is calculation, which can be actually much trickier. So really got to think and pay attention to the words that you're reading. A function is a mathematical relation that maps a set of input values that we've called x in the past to a set of output values, which we've called y, or started writing it in function notation as f of x. That each input value is mapped to exactly 1. That's the key, output. Every incoming x comes out as only one y value. Change in tandem, which is just kind of a new phrase, means that the input and output will vary together. As one changes, the other changes as well. Maybe as x goes up, so does y. Maybe it's different, but change in tandem is just referring to the fact that they are related to each other. Like a tandem bike, you have 2 bikers on one. Obviously, what one does affects the other. Same thing here. Okay. In previous courses, you have used the vertical line test. Yes, we have, to determine if a graph is a function or not. You can still use that, but, and this is really important to know, this is going to go into a yellow highlighting for sure because it's on the AP test and it's telling you straight up. In AP Pre-Calc, we will use the statement, each input has exactly one output, meaning you're going to need to write those exact words on your AP Pre-Calc test when you are explaining why a given relation is a function. Okay, so just make sure that that's something that you really highlight in your notes and kind of keep in mind. The set of input values of a function is called, these lines are so small for my messy writing, is called the domain. And it's represented by what we call the independent variable. When you guys make an XY table back in the day, you could kind of just pick whatever x's you wanted. They were independent, separate. And then the set of output is going to be the range, not shocking, not a new term. And that's represented by the dependent. And that's because the y value depends on what you plug in for x. So I can pick 2 as my x value, but then what I get for y will depend on the function and what it does to that too. So those are kind of terms that we already know, but they are still important definitions that you want to know. Okay. A function is what we call positive. I'm not even going to try to write positive in that little spot. When the graph of f lies above the x-axis. Okay, this is something you got to kind of start thinking about. This does get confusing because you have to pay attention to what are they referring to, what are they asking about. So if I just have a function and it's doing this, that function is positive. So this is my function, f of x. It is positive when it is above the x-axis because that is where you have positive y's. So keep in mind that that would be here and here. Those are places where my y is positive. And so my y values are going to be greater than 0. Not surprisingly, if a function is negative, then that's going to be where it's below the x-axis because that's where your negative y's are. So it's talking about the function's value being above or below. So you're going to have positive f of x is greater than 0, which just means a positive y. If your function's negative, then your f of x is less than 0 or any place that the y is negative. So this is going to be above the x-axis. This is going to be below. And then obviously, well, maybe it's not obvious, but if your value was actually 0, then it's going to be on the x-axis. So that's a concept that you touched on in Algebra 2, but it's going to be really important to have a solid handle on that. So I'll let that kind of sink in, that concept. And I'm going to go ahead and highlight that green concept so I know where to look for that. All right. This little weird, oh, I didn't finish, sorry. It says that it lies below the x-axis and the outputs are therefore less than 0 because you're talking about positive or negative. So anything above the x-axis has a positive function value, and anything below is a negative value. So here we're describing the actual y values. So that's important to keep in mind because we're going to talk about positive and negative a lot, and you have to decide which thing is positive or negative. Here we have ye old jug. The figure shows an empty vase. Oops, just kidding, it's a vase. At time 0, the water begins pouring into the vase at a constant rate until it's full. Which of the following, this is what I'm talking about, this is concept, not calculation, could depict the situation where time in seconds is the independent variable, so x is time, and time is increasing because we are letting time pass. The height of the water is the dependent variable, so y is representing the water height. Now, the water height will be increasing. The question is, which of these graphs shows the rate at which it's increasing? So if you are filling this, you're pouring water in here, and this is getting taller and taller, higher as you go, it is not going to get higher at a constant rate because the sides of the vase are wide and then skinny. And so you know from life experience that when you're filling this thing up in this region where the vase is getting fat, it's going to take longer for that height to increase. Like it won't be increasing quickly. But when you go towards the top here, which would be further into your time, right? Because it'd be at the end of the time that you're filling it. This is going to get taller or higher faster because you just have that skinny little bottleneck. But overall, it's always increasing. So we need to find a graph where the height is always increasing, starts at 0, and at first you have a region of kind of slower height growth, and then at the top or towards the end of the time, it would get taller faster or higher faster. So think about what you have. I'm going to rule out A. Why? Because this is showing that it's constant. The only way it's going to be constant is if like I had a cylindrical vase. Then the height of the water would increase at a constant rate. That's not what's happening. Sad face. I'm also going to eliminate C because it has to always be increasing, and you can see here there's a spot where this one is decreasing. So that can't be it. So sad face for that one as well. Okay, we only have 2 left. So let's take a look. Here, this is showing very slow at first, and then it's showing faster, and then it's showing slower growth. So this one is kind of slow here, meaning it's not increasing very quickly. Then it does increase quickly, but it's slow again at the end. And we know that at the end, meaning the top of the vase, that part wouldn't happen. So this part here is helping me eliminate option B. So I'm going to go with D as my answer because it starts off kind of quickly, but then as the vase gets fatter here from this time period, it kind of slows down in terms of how tall it gets. But then towards the end, as the radius of the vase gets small, it starts to speed up in terms of how fast it is filling up. So that's going to be the best match. That, my friends, is concept. And so that conceptual thinking can be really tricky, but that's going to be an important aspect to what we do when we're taking our AP Pre-Calc test. Okay, get your big brain on. This is super important to know, and it's super important to think about when you're reading. The words in matter so much. And even in calculus, I always ask my students to think about when you're being told to do something or asked to do something, ask yourself, what does that mean? And change it into words and things that you are used to. Because again, there's no calculation in this, it's just concept. So we're going to be analyzing graphs. Increasing as the as the input values, meaning the x's, go up, then it says the output values always increase. Okay, so it doesn't have to be a straight line, but from left to right, it's always going up. That's increasing. Decreasing is talking about the value. These two are talking about the actual value of the graph, the y value. Are the y's going up or are the y's going down? So this is going to be going up. These are going to be coming down. Don't have to be in a line. They just have to be decreasing. So here, as you go from left to right, your x's will increase in value, but you can see that your y values are going down. So that's something you have done. You have been able to look at a graph and decide if things are going up or down. This is a new concept over here, and so pay attention to this part. If the graph is concave up, you might have talked about it as like opens up. What I think of it is I shorten this concave up to C-U-P. It looks like a cup, and it is opening upward. Versus concave down, which I abbreviate as CD, this one opens downward. And so you think of it as which direction is it opening? Is it opening up or is it opening down, like an upside down cup? Now, here's the tricky part. This is not referring to the value because it says the rate of change is increasing. So the rate of change is increasing when a function is concave up, not the value. Because when you look at this graph, it looks like the values are not increasing all the time, but the rate of change is. The rate of change is essentially how fast is each thing changing. So let's give a value to this as if it was a slope. Let's pretend this is at like -5, but as I go, this is now just -4, and then maybe it's -3, and then maybe it's -2. And then as I get down here, maybe it's only -1/2, and then at the bottom, it's 0. Slope. And slope is measuring my rate of change. Here it starts going back up at like 1/2, then somewhere it's 1, somewhere it's going up 2/1, then 3/1, then 4/1. So if you look at those numbers, -5, -4, -3, -2, -1/2, 0, 1, 2, 3, 4, those are increasing. So your brain wants to look at that and be like, nuh-uh, that's not increasing. That's because you're looking at the graph and we're not looking at the values of the graph like we were with increase and decrease. We're looking at the rate of change. How is the rate of change changing? So get it in your brain that concave up is going to indicate that in that region or interval, the rate of change is increasing. Same exact concept with concave down, except the rate of change is decreasing. So again, if I wrote little slope values for these, maybe it would be 5, 4, 3, 2, 1, 1/2, 0, -1/2, -1, 2, 3, 4. So this one, if I mapped the rate of change at each of these spots, that number would be going down. Obviously, this picture is going up and then down. That's what made it concave down. So what you want to associate is concave up, the rate of change is increasing. Concave down, the rate of change is decreasing. This is a super important thing to know, and you have to really pay attention and slow yourself down. Are they asking about the values? Or are they asking about the rate of change and how that's changing? So really pay attention to that as you go. Now, when we get into describing where different things are increasing or decreasing, we're going to use what are called intervals. And when you describe intervals, you are only going to use X values. And you're going to use the interval notation that we talked about in 1.2. So you are never on an interval, because you're telling where it's happening, you're never going to use your Y value, because you're describing where. You're saying from here to here, the graph is doing this thing. So we will always use X variable when writing intervals. So let's look at what a problem would look like. The figure shows the graph of a piecewise function over the interval from 0 to 9. What are all the intervals where the graph is increasing? So ask yourself, what does that mean? That simply means that it is going up. You are perfectly capable of saying, oh, it's going up here and it's going up here. So those two parts are going to be what I want to describe. So here it's increasing, decreasing, and increasing. I'm supposed to write them as intervals. So X values. This is the interval from left to right where it's increasing. The X value on the left end of that is at the Y-axis, which is 0, and the X value on the right end of that is at 3. Then from 3 to 7, it's decreasing, but from 7 to the end, which is 9, it's increasing again. So when I go to list like it said, all of the intervals, I'm going to be describing from 0 to 3. Now, it's not increasing at 0 or 3 or 7 or 9. It's at a peak or a valley. It's changing directions. So these are going to be non-inclusive. I'm not going to include those numbers. So in algebra, we would have said X is between 0 and 3, not inclusive. But in interval notation, that will be parentheses saying from 0 to 3, it's increasing. And then again from 7 to 9, not including. So I would have 7 on the low end, 9 on the high end. X's in between there are increasing. So you're just describing where that's happening. Okay, so rate of change simply means slope. How steep is it? And this will vary. This will be a very commonly used phrase. If you watch the 1-2 video first, then we already talked about that. And you want to make sure that that's a concept you have, like, without even thinking. You should be able to say, rate of change, that's going to be my slope value. Okay, so again, you have to read really carefully. These next two boxes are so important. I'm going to go ahead and highlight that whole box because I need to know how all of these things are the same and how they are different. So looking at this first graph, it says F is positive. That is talking about the Y values, meaning that it is above the x-axis. This whole entire graph over here is above the x-axis. Every single Y value is positive. That's what it's referring to. The second bullet, F is decreasing. Yes, it is, meaning this graph is going down from left to right. So F is decreasing. Again, you're looking at the Y values, and they are decreasing from left to right. Now, the last one's the doozy. It says the rate of change of F is increasing. How do I know that? Because this whole graph is concave up. The curvature is opening upward. This is going to be the newest concept and the trickiest one to wrap your brain around. In this second picture, I have a graph that's doing this little thing. What do you notice about it? The entire thing is below the x-axis, so that makes the function itself negative. So saying g is negative, you're indicating that it's below the x-axis. But if I'm on there riding the rails from left to right, the whole entire time I'm going up, sometimes faster, sometimes more slowly, but it's increasing because the Y values increase or go up from left to right. And then the doozy big brainer is the last one. This one, the concavity is opening down. You can see this curvature is going like that. It's opening downward. The cup is upside downish. And so that indicates that the rate of change is changing at a decreasing manner. So understanding and being able to answer questions about, hey, is the function positive or negative? All that means is above or below. Is it increasing or decreasing? Means are the Y values going up or down? And then is the rate of change increasing or decreasing? That's asking about concavity. So you really have to dig into that to make that make sense. Okay, we have a lot of examples. So I'm going to end this video and have the notes be separate from the examples. And then if you want to, you can try the examples on your own and then watch the other video to go through them with me. Thanks, guys.